What is KVL? Algebraic sum of EMFs plus potential drops equal to 0. This way we can remember. Algebraic sum of EMFs plus potential drops equal to 0. What is KCL? Algebraic sum of currents in a junction. Algebraic sum of currents, all currents I equals to 0 at any junction. At any junction. So that's all. KVL is algebraic sum of EMF, all EMFs and potential difference in a loop. In a loop, that is important. In a loop. Kirchhoff. Five volt, 6 volt, 5 ohm, 6 ohm, 7 ohm. We'll solve by using both KVL as well as KCL. Let us assume that current through this path is I1. Current through this path is I2. Therefore, current through this path is I1 minus I2. Here, current entering here is I1 minus I2. Here, current entering is I2. If you add these two together, we got again I1. Now, let us take the loop A, B, C, D, A. Consider the loop A, B, C, D, A. For that, what is the loop equation? Write KVL. If you write KVL, we are traveling from A to B, raise in potential, that's why plus 5. We are traveling along current direction, there is a fall in potential. When we travel from B to C, that's why minus, fall in potential, minus 6 I2. Along CD, no elements. From DA, again we are traveling along current direction, that's why minus I1 equal to 0, or 5 I1 plus 6 I2 equal to 5. This is first equation. If you write the equation for second loop, this is first loop, this is second loop. If you write the equation for second loop, if you travel along B, E, F, C, B, B, E, F, C, B. You can travel any path you can select. You can select B, C, F, E, B also you can select. So if you select the B, there is a raise in potential, that's why plus 6. There is a fall in potential in 7 ohm, that is minus 7 I1 minus I2. There is no element in FC, but CB there is a resistance 6 ohm, but we are traveling against current direction. That's why raise in potential 6 times I2 equal to 0. If you simplify this, minus 7 I1 plus 7 I2 plus 6 I2 equal to minus 6, or we can write this is equal to 7 I1 minus 13 I2 equal to 6. Am I correct or not? Let it be the second equation. Solve these two and find I2 is required. So first equation multiplied by 7. 35, this implies 35 I1 plus 42 I2 equal to 35. Second equation multiplied by 5. This implies 35 I1 that 65 minus 65 I2 equal to 30. We subtract third, this is third equation, this is fourth. Subtract 4 from 3, you will get these two getting cancelled. This becomes 107, 107 I2 equal to 35 minus 30 equal to 5. Therefore, I2 equal to 5 divided by 107 equal to how much? 0.046 amperes. So we got. Let us solve this sum by using KCL. Before doing that, let us solve this by Millman's theorem. Loop equations. Let us solve this by using five ohm, 6 ohm, 7 ohm, 6 volt, 5 volt. This is current is I1. This is I2. Therefore, R11 is sum of elements in the first loop. That is 6 plus 5 equal to 11. And common to first loop and second loop is the second element, R12. First and second, minus 6. Why minus 6? Because I1 is this way, I2 is this way. That's why minus. Again, here also minus, common to second loop and first loop. The elements in second loop is 13. Therefore, I1, I2 equal to, what is V1 is? We have to check while traveling along current direction, is there any increase in voltage? Yes, there is an increase in voltage. That's why plus 5. Here also there is, if you travel along current direction, there is an increase in voltage. That's why plus 6. This is very important. Simply we cannot put 5 and 6. We have to check whether it is along the current direction. So 5, 6. Therefore, I2 equal to what? I1 equal to what? We have to find both, because current through 6 ohm we have to find. Find current through 6 ohm. The question is I6 ohm equal to what? I2 we have to find. I didn't mention that. We have to find current through 6 ohm. Here also we have to find current through 6 ohm. That is I1 minus I2. Therefore, we have to find both. Here I6 ohm equal to what? I6 ohm equal to I1 minus I2. Here I6 ohm equal to simply I2. This is what on the day one student asked. That's why one more sum I am solving. I am leaving incomplete all sums. I thought of leaving incomplete, but hereafter I won't do, because you all get confusion. So I6 ohm equal to I2 in the first part. Why? We are assuming that current through 6 ohm equal to I2. In the second case, as rightly mentioned by some students there, who rightly mentioned, sir, I1 minus I2, who said? Yes. So I also didn't mention. He correctly mentioned I1 minus I2. Current through 6 ohm is I1 minus I2. Why? Because current through that path, both currents are going through that 6 ohm, I1 as well as I2. Therefore, 6 ohm equal to current through 6 ohm equal to I1 minus I2. That's why we have to find both. I1 equal to determinant of this by replacing first column by right hand side. Therefore, 5, 6, minus 6 and 13 divided by determinant of A, that is 11, minus 6 and 13. Cramer's rule. By using that, you can find I1. I1 equal to, find I1. Point. Yes, 0.943. 0.943. I2 equal to what? I2 equal to, we have to replace the second column. 0.897. Yes. Replace the second column. What is that? So we have to write the first column as such 11 and minus 6. Replace the second column by Cramer's rule. What you will get? 5, 6 divided by 11. Determinant of 11 minus 6 minus 6, 13. That is equal to 0.87. Therefore, I6 ohm equal to I6 ohm equal to I1 minus I2. That is the 0.943 minus 0.897 equal to how much? 0.046. We got the same answer in both ways. These two are based on KVL, Kirchhoff's voltage law. One is by using KVL, another one is based on loop current method. Now let us solve this same sum by using Kirchhoff's current law, KCL. If you use KCL, 5 volt, 6 volt, 5 ohm, 6 ohm, 7 ohm. How many nodes are there? Actually, it is misnamed. Node means junction of two paths. Junction is the correct word. It's named. Anyhow, node means at least 3 junction. As far as nodal equation is concerned, 3 paths has to meet. Here, 3 paths are meeting where and all? One at A, another one is at B. So let us call this as V, unknown voltage at A. Unknown voltage at A is VA. We can call it as VA. This voltage, unknown voltage at B is VB. We can take any one of these nodes as reference. We have to take any one of these nodes as reference. Let us call VB as node, V reference. So how many nodes left? Only one. If you assume V reference equal to 0, we can assume V reference equal to 0 volt. Let us assume what is that? We are taking that reference as 0. Now we have to find VA. If you know VA, that is nodal method. We can apply KCL, Kirchhoff's current law. If you know VA, we can find what is the current through this, what is current through this, what is current through this, we can find. So what is current through 5 ohm? That is I5. What is current through 6 ohm is I6. Current through 7 ohm is I7. So we have to find all these 3. I5 is entering the junction VA. I5 is entering the junction VA. I6 is leaving the junction VA. I7 is leaving the junction VA. Am I correct or not? Okay. So if the current entering the junction means positive, the current is leaving means negative. So if we spend something, negative. If we get something, positive. So in the same way, junction gets something, that's why positive. Junction loses something, that's why negative. So if you assume what is the current through what is the current through 5 ohm? So we can write this way: algebraic sum of I5 plus I6 plus I7 equal to 0. So or I can say that I5 is coming, that's why plus I5 minus I6 minus I7 equal to 0. Algebraic sum of, am I correct or not? I5 is entering, I6 is leaving, I7 also leaving. That's why I wrote KCL, Kirchhoff's current law I wrote. Now I have to find I5. What is I5? I5 equal to what? If we want current through 5 ohm, we have to find the voltage across 5 ohm. This circuit is identical to, if I put another way, you will tell. What I am going to do is, just to understand, I am modifying this circuit this way. Both are same. Both are same. You can put the element in that branch anywhere. Same effect. Anywhere. But current should not change. Current should not change. If you put here, or here, current is same I1. Sorry, current is same I5. Now you can tell what is the voltage across 5 ohm. This is 5 volt. This is 6 volt. What is the voltage? What is the current through 5 ohm? Here, what is the voltage? Here, V reference. V reference equal to 0. What is voltage across 5 ohm? What is the direction of current? What is the direction of current here? What is the direction of current in 7 ohm? These are the directions. Am I correct or not? Can you tell what is the current in 5 ohm? A second figure. Refer second figure. Huh? 1 ampere. What is the current through a single element? We have to consider both ends. One end, what is the voltage? 5 volt. Another end, what is the voltage? VA. This end, that is the problem. This end, here 0, here 0, here 5 volt. Am I correct or not? Voltage across 5 ohm is 5 minus VA. Am I correct or not? From second figure, you are understanding. But in the first figure also same 5 minus VA. First figure, the resistance can be anywhere. Mentally, you have to assume that if two sources are there, you have to assume that the resistances are in between these two. Mentally, you have to assume. You understand this? This is very important while writing KCL. So you have to mentally assume that it is between two voltages. If you assume that, you will get. So 5 minus VA. Therefore, I5 equal to 5 minus VA divided by 5. 5 volt minus VA. Because this is reference, that's why this is 5 volt. Here VA. Current is this direction. That's why 5 is greater than VA. Why am I writing not VA minus 5? Why I didn't write? Because current direction is from 5 volt to VA. Therefore, 5 is higher. That's why 5 minus VA divided by 5. I6 equal to what? What is the VA equal to? We do not know. That's why VA, other end is 0. VA minus 0. Because we are assuming that V reference equal to 0. Therefore, VA divided by 6. What is I7? What is the current direction? VA to reference. So VA is higher. That's why definitely VA. VA minus. Here you consider. If it is in the other way, VA minus 6 is correct. But it is inverted. It is inverted. You are digging a well means you are in the first floor. There is no well. The depth is 10 feet. If you are in the first floor means. But in the ground, you digged a well, another 10 feet. What is the depth? 20 feet. Here, you connected in the reverse. That's why here, the voltage already minus 6. Am I correct or not? Here 0. Here it is in the reference. Here it is minus 6. Am I correct or not? Plus 6 or minus 6. If you travel from the reference, minus 6. So, what you are doing is correct. VA minus of minus 6. Minus of minus 6. Therefore, VA plus 6 divided by 7. VA plus 6 divided by 7. Substitute in this first equation. Substitute in the first equation. What you will get? 5 minus VA divided by 5 minus. Why minus? Current is leaving from the junction. Current is leaving from the junction. What you got? VA divided by 6. Again minus. Current is leaving from the junction. in 7 ohm resistance, that is VA plus 6 divided by 7. This minus sign, current is leaving. Here current is entering. Y plus, current is entering the junction. Equal to 0. Algebraic sum of total current equal to 0. Now we can write 5 by 5 minus VA by 5 minus VA by 6 minus VA by 7 minus 6 by 7 equal to 0. So we have to group all VAs. What you will get? VA minus 1 by 5 minus 1 by 6 minus 1 by 7 equal to 6 by 7 minus 1. Or you can write 210 42 minus 35 minus 30 VA equal to 7 minus 6 minus 1 by 7. So minus sign getting cancelled. 110, am I correct? 101. 107, yes. 107. Therefore, VA equal to 1 by 7 multiplied by 210 divided by 107 equal to how much? 0. 0.3 sorry 28, no? VA equal to 0.28, am I correct? VA equal to 0.28 volts. Therefore, I6 equal to what? VA divided by 6. Therefore, 0.28 divided by 6 equal to, that is the answer, you know, earlier. Here also that 0.047, am I? Okay. Okay. That is equal to 0.047. Here also 0.047 or 46 amperes. So we got in both ways we got the same current.